Okay, so now we'll do revision for topic 17. Now for topic 18. So topic 18 is one of very popular in SPM. If you look at real reaction past year, 20 years or past years, right, you realize that acid plus metal is the one that most frequent come out up. Well, why this happened? Because acid plus metal, right, it has many potential factors they can ask in the exam. So for example, let's say we talk about the metal is zinc, then the acid is HCl. Let's give some example. So imagine for this experiment, zinc and the acid is HCl, right? Zinc is a solid form. You can adjust the rate of reaction by change the size, which is powder will have higher rate of reaction. Then because hydrochloric acid is a liquid, you can adjust the concentration, which is higher concentration will have a higher rate of reaction. Okay. Then you also can heat up the liquid so that higher temperature will also increase the rate of reaction. Then any acid, no matter it's HCl, H2SO4, HNO3, any metal like zinc, magnesium, aluminum, when acid plus metal, there will be one catalyst you need to memorize, which is copper 2 sulfate. So this one is easily will give you a 1 free marks. You'll give you 1 free marks. Okay, you have to know any acid plus any metal. If you want to make the reaction faster, you can use copper 2 sulfate solution to accelerate the reaction. Okay, so this is the first one. Then after that, there's one hidden factor as well that although both solution looks the same, example, let's say both solutions are 50 cm3, 1 mole per dm3. This is called hidden factor. It looks like they all have same concentration, same volume, same number of mole, but actually the hydrogen is different because HCl were able to produce 1 H+. But my sulfuric acid were able to produce 2 H+. So although everything looks the same, but the concentration of hydrogen ion for sulfuric acid is double the hydrochloric acid. Okay, so this is you can see it can come out 5 different factors in the same questions. Okay, so this is the first one, the factor things. Then the second thing is about the chemical equation and ionic equation. The chemical equation and ionic equation is very important because it actually decides what you need to write in the collision theory. So we see zinc. Okay, this is zinc. I put into hydrochloric acid. Okay, after the reaction, what happened? The zinc has dissolved, become zinc chloride. Then the hydrogen become gas. Now for ionic equation, what is the purpose of ionic equation? Ionic equation is for us to know which is the actual chemical that actually reacting. Which is the actual chemical that actually reacting. So you have to find out who is actually no changes. Okay, so very obvious who has no changes. You can see zinc has changed to zinc ion. So it has changes. Then the hydrogen ion has changed to hydrogen molecule, which is gas. Then my chloride ion, you realize that no change before is Cl minus, after is Cl minus, is also still in solution. So there will be no change here. So my ionic equation, I will cancel it. So you can see the actually reacting is my zinc atom is actually reacting with hydrogen ion. That's why my ionic equation is Zn become react with 2H plus, it becomes Zn2 plus H2. Okay, so what is important about this ionic equation? Because whenever you write about the frequency of collision, you must mention about zinc atom and hydrogen ion. Okay, so this is one that you have to know. So I roughly go through the collision theory. So first, size. Okay, when the size smaller, the total surface area of zinc, you must write total, exposed to hydrochloric acid will be bigger, will be higher. So when more surface, frequency of collision between zinc atom and hydrogen ion will be higher. Then frequency effective collision will increase, then rate of reaction will increase. So this is the first one. Then the next one, if you increase the concentration, because H plus and Cl minus, right? Cl minus is not involved, so you just mentioned about there are more hydrogen ion per unit volume. It's something like let's say this two is the same. Okay, just copy and paste so that it looks the same. Higher concentration means it has more H plus. So this is dilute. This is concentrated. So imagine in a lift, you have more people inside. When you have more people inside, of course, collision will be more because very packed, very close to each other. You'll collect here, collect there, like this. Okay. So remember, collision and effective collision one is different. Collision means successful collision. So frequency of collision is you collect maybe 100 times. Frequency of effective collision maybe 10 times. So when you increase your frequency of collision to 1,000 times, of course, your effective collision, successful collision will increase to 100 times. Okay, so this is the idea. Then if you increase the temperature, same thing, I only talk about hydrogen ion because chloride I cancel off anymore. So the hydrogen ion will move faster because when hot particle will move faster. When move faster, of course, you'll collect more. Then frequency of collision increase, then frequency effective collision increase, rate of reaction increase. Then copper 2 sulfate solution is the catalyst. Okay, they provide a shortcut like what we learned in topic 17, which require lower exchange energy, more particle able to achieve lower exchange energy. But remember, frequency of collision does not increase, only frequency effective collision increase. If you forgot about the catalyst, you can refer back to topic 17 video again. Okay, so this is the idea. So we try this question. We look at this question. 2 experiments was carried out to study the rate of reaction between hydrochloric acid and zinc. So based on this experiment, so this is a specific, you must mention about this thing. How do we know the rate of reaction? You take the volume of hydrogen gas released, divide by time taken. Okay, so for example, we can look at the part B. For experiment 1, it was able to collect 50 cm³ of hydrogen gas. For experiment 1, will take 60 seconds to collect. Experiment 2 will take 20 seconds. So how do I calculate the rate of reaction? One is I take 50 divided by 60 seconds. I'll get 0.83333. The other one, I'll take 50 divided by 20 seconds. I'll get 2.5 seconds. Then they always ask you about the ionic equations. So ionic equation, first thing you write down the equation first. Zinc plus hydrochloric acid. Okay, Zn and Cl go together. Then H2 will come up. Balance equation, put a 2 here. Then we try to cancel out the thing that Cl minus is not in effect. So the ionic equation will be Zn plus 2H plus. It becomes Zn2 plus H2. Compare the rate of reaction based on these two numbers. Who is actually has higher rate of reaction will be this one. So experiment 2. Okay, you must write this. The rate of reaction for experiment 2 is higher than the rate of reaction for experiment 1. Then using collision theory, explain what factor. We check here, what is the factor make it actually higher rate of reaction is because of this higher concentration. Higher concentration. So we see when concentration higher, particle per unit volume will be higher, then frequency of collision will be higher, frequency of effective collision will be higher, then rate of reaction will be higher. So you can start with the first one now. Experiment 2 use a higher concentration of hydrochloric acid. Then, as I told you, the number of hydrogen ion per unit volume inside, because as I told you before, H plus and Cl minus, we cancel the Cl minus mark. So we don't mention about Cl minus later because the one that actually reacting is hydrogen ion. Then after that, the frequency of collision between hydrogen ion and zinc atom is higher. Then frequency of effective collision between hydrogen ion and zinc atom is higher. Then rate of reaction increase. So you see, if in exam they change the chemical into magnesium react with nitric acid, all you need to do is just change. Okay, so you need to all you need to do is just change this to a nitric acid. This one remain the same. Then this one you change to magnesium atom, that is. I underline the chemical words so that it's easier for you to change your answer for the next one. Okay. Now after that, calculate the maximum volume of gas that at room temperature for experiment 2. So we look at what we have now. We have, this is the V, this is the M. So first we calculate how much, for experiment 2, how much the M and V means the MV of 1000 to find out the number of mole first. So number of mole HCl, I will get 0.05. Okay. Then after that, based on the reaction, for the hydrochloric acid and the gas release ratio is 2 to 1. 2 to 1. So 2 HCl will produce 1 H2. Then you can write out the sentence. 2 HCl will produce 1 H2. So 0.05 will get 0.025 mole of hydrogen gas. Then after that, you bring the 0.025 mole times the molar volume, you'll get how many cm3. Okay, so this is the basic calculation. Then we try the second question to see the difference. Same thing here. It also zinc plus hydrochloric acid. So first thing, write down a chemical equation first. Then what they want now is they want to calculate the volume, maximum volume for hydrogen gas to produce at set 1. So look at set 1 here. So this is your M, this is your V. So use MV or 1000 to get your number of mole. Then we look at the ratio again. 2 mole produce 1 mole. So 0.05 will produce 0.025. Then bring this over here to find the volume. So the mole is 0.0525. Then after that, the volume over 24, you'll get 600 again. Then compare the reaction for set 1 and set 2. Look at the reaction for set 1, set 2. Now for set 1, set 2, you can see set 2 as you use shorter time. So the reaction for number 2 is higher than number 1. Then we compare set 2 and set 3. Set 2 and set 3 also, set 3 has higher reaction because it completes in shorter time. Refer the correlation theory, explain your answer in B1 or B2. So we need to explain the reason. We check here. The reason why set 1 and set 2 difference, I think, is this one. So this is higher concentration. For set 1 and set 3, I think the reason is here, higher temperature. Okay, so look at the answer, what they achieved. My answer would be refer to set 2. So same as this one, higher concentration, exactly same as this one, that the number of hydrogen ion is higher, then pyrimidine bond is higher, hydrogen ion, frequency collision will increase between the hydrogen ion and zinc atom, then frequency effective collision between hydrogen ion and zinc atom. Okay, so you can see we just done 2 questions, very similar question. Okay, now one thing for chemistry, right, you keep copy the answer is actually does not help too much. So since we done the first question and second question, okay, can you try the third question, fourth question, fifth question by yourself? You try this one, slightly different, but you try it. Okay, so please pause the video first. When you complete the third question, then you continue play the video to check the answer. Then you use your red pen to mark your answer. Then you try question 4 one more time. So I believe until question 5, you should become confident. Okay, so please pause the video now. Okay, good. Assuming you've done it, so you try this one. This one slightly changed magnesium plus hydrochloric acid. So the one that no change will be this one. So ionic equation will be Mg plus 2H plus become Mg2 plus H2. Okay, then calculate the maximum volume. So we check here, what do we have? We have 0.5 mole, 0.5 gram of magnesium powder. So first use the mass or molar mass to get your mole first. Then we look at the ratio between the magnesium and the hydrogen gas is 1 to 1. So 1 mole produce 1 mole, so 0.021 will get 0.021 as well. Now after that, you can convert it to 0.021 here, you'll get a volume equals to 0.5. Okay, now look at this experiment now. They ask you to plot the graph mark. Okay, so you can see here, experiment 1 is higher rate of reaction. Why? Because experiment 1, they actually experiment 1 is higher because it's using powder. So the factor here is size. The factor here is size. So for size, right? Okay, in size smaller, okay, the total surface area exposed to the acid will be higher. Then frequency of collision higher, frequency of effective collision higher, then rate of reaction higher. So first one, the size, magnesium powder has smaller size than magnesium ribbon. So the total surface area of magnesium exposed to hydrochloric acid will be higher. So frequency of collision between magnesium atom and hydrogen ion is higher in experiment 1. Then frequency of effective collision between these two will be higher at experiment 1. Yeah, so this is the answer. So you try question 4 by yourself again. You need to really try to solve the question, but rather than just keep copying the answer, because you won't be able to help you just copy because you don't know what you're copying. And then when you try to write the answer by yourself, you actually you're getting better because when you write out, then you mark using the red pen, you know which keywords you're missing. Okay, so you try one time, pause the video now, copy the question, then open up the video and try. Okay, assuming it's done already, so we check what is the question here. Chemical equation for set 1, we check here. This is zinc plus hydrochloric acid. So we write the chemical equation first. Zinc plus hydrochloric acid, it becomes zinc chloride plus H2. Calculate the volume released at set 1. We check one. Set 1 here, we have this M and V. So use MV on 1000. So I get 0.05. Then the ratio is 2 to 1. So I get the 0.05 becomes 0.025. Then from there, I'm able to calculate my volume is 60 TM3. Okay. Sketch the energy profile diagram for set 1 and set 2. So look at set 2. You realize that set 2 has this one. This is the catalyst. You remember acid plus metal, the catalyst is copper 2 sulfate. Always ask in the exam. Okay. So the catalyst will be lower activation energy. Then compare set 2 and set 3. We check here. Set 2 and set 3, which one should be a higher rate reaction? We check here. Or both also got catalyst. But one is hydrochloric acid, one is sulfuric acid. You can say this is called hidden factor. Both looks the same. Everything looks the same, but sulfuric acid actually has higher reaction. Why? First, one is diaprotic acid, one is monoprotic acid. So sulfuric acid will produce double concentrate. You're able to produce double H plus compared to hydrochloric acid. So when the concentrate acid is higher, means the number of hydrogen ion per unit volume also double. So frequency of collision between zinc atom and hydrogen ion is higher. Frequency of effective collision also higher. Then rate of reaction also higher. Okay, so you try question 5 by yourself. You need to try facing new questions. So pause the video now. Assuming it's done already, the equation will be same thing, zinc plus hydrochloric acid becomes zinc chloride plus H2. Okay. The gas release is this one. How do we test? We can use the lighter wind sprinter. You have a pop sound. Predict the rate of reaction for 180 seconds. After 180 seconds, you can see the reaction has stopped. Okay, so average rate of reaction for first minute. Okay, look at the first minute. First minute is 60 seconds. It released 66. So it takes 66 divided by 60. I get 1.1 cm cube. For second minute, okay, for second minute, is between here. It's between first minute and second minute. Okay, because this is first minute. Here to here is first minute. Here to here is second minute. Okay, so you take the 60, 120, you minus 75 minus 66. Then 120 minus 60, you get 0.15. Why there's different average reaction for first one and second one? Because the concentration will drop off. Because imagine this is acid, you put your hand inside. At the beginning, very strong, very fast sound. But as the gassing acid getting lesser and lesser, you will heard the sound of like this lesser acid. say relationship between the gradient and the redirection. The steeper the gradient, steeper means like this, means the redirection is higher. The less steep means the redirection is lower. Okay, just sketch a graph between for the concentration of acid, it actually will continue to drop until zero. Now, whether you drop until zero or not will depends on who is excess. We check here. Can you see? Excess is zinc powder. So my acid will be finished. If excess is hydrochloric acid, your graph won't drop to zero. Your graph maybe will drop to here. We still have some excess here. So you have to look at the question to see which one is the correct answer.